Good morning, guys. So today I will continue with the series of vectors. Okay. So last time we did what we call we defined what is the vector and what is a scalar, and then we did do some operations, multiplication, addition and subtraction, and then we did a dot product, okay, or scalar product. Okay. So from what we did last time, we said that a vector A, that has A, B, C component, right? And vector B, that has X, Y, and Z component vectors. So vector A dot vector B, alright? It gives you what? It gives you A multiplied by X plus B multiplied by Y plus C multiplied by Z. And then we say the result of dot product, we call it dot product or scalar product, okay? The result is a scalar. A scalar, we say that it was a quantity that has a magnitude only. But a vector is a quantity that has magnitude and a direction. Okay? So there is another formula for a dot product. A times B, like this, dot B. It gives you the magnitude of A multiplied by the magnitude of B times cos of theta. Cos of theta. Alright? So this formula will help you to find the angle between two vectors. Okay? Now, there's another property that says vector A is parallel to is perpendicular to vector B if A dot B equal to 0. Alright? We say vector A, this is vector A, and then I'm having vector B, for instance. These two are perpendicular. Perpendicular, it means what? It means the angle between A and B, the angle between A and B, the angle between them is 90 degrees. It means it's perpendicular. Okay? 90 degrees, or in brackets it's going to be pi over 2. Alright? So the rule says if you do the dot product of A and B, it gives you 0. It means they are both perpendicular. They are perpendicular one another. Alright? Let us do some examples. Alright? I'll get the question from this book. And there was one point that we said yesterday, very crucial point, regarding this first part. It was a vector V, vector 1, okay? The component of vector V, the component of vector V1, let me write it, component of vector V1 in the direction of V2 is equal to, okay, v1 dot v2 divided by the modulus or the magnitude of v2, like this. All right. So there is a question 10 in your book. It's exercise 3. Activity 10. All right. They are asking, what is the component of vector? The vector 2I plus 7j in the direction of I. Okay. Let me write it so that you can see. They said determine. Okay. The component of vector 2I plus 7j in the direction of vector I. All right. How do you solve it? Now, I like to call. You have to give the vector name. Okay. Let me give it the name as A. Okay. A equal to what? 2I plus 7j. I like to write it in this format. It's the same as A equal to 2, all right, and then 7, right? Okay. And then the second vector I, let me call it B. It is I like this. This one is equal to B like this. It's I is going to be 1, and then J is going to be 0. Remember, I want to emphasize, you do, they must be in the same plane for you to do the operations. So you cannot have a 3D here and then a 2D here. No. It should be 2D, 2D, or 3D, 3D. Okay? So I equal to 1 and 0. Okay? This is your I. This is your J, alright? This is your I, this is your J, alright? Okay? Alright, good. So now, let us find the component of vector 2I plus 7j in the direction of I. Okay, here we call I our vector B. It means B will be equal to the product, the scalar product of A times B to the direction of what? Of B. Okay? In case you didn't name anything, it's going to be we're looking for vector I, so it's going to give you the vector, the first vector, which is 2 and 7, like this. 2 and 7 multiplied by 1 and 0, and then the modulus of 1 and 0. The modulus of 1 and 0. So let us do it. Okay? So it's gonna be R equal to A times B. A times B is gonna be. Do you know how to solve? How to do it? There's a formula here. Okay? It's gonna give you what? 2 times 1 plus 7 times 0. 2 times 1 plus 7 times 0. Alright? This one gonna give you 2 here, and this one gonna give you 0. So I'm gonna keep only 2. And down here it's gonna give me square root of 1 squared plus 0 squared, which is gonna give you only 1. Alright? So I'm gonna add 2 divided by square root of 1, which is 1. Alright? So this is the answer. The answer will be the component of vector 2i plus 2j plus 7j in the direction of I, it will be 2. Alright? That's it. Let's go to the next question. Next question. Question 11. Let's see question 11. Question 11, it says, they give you two vectors. A equal to 7i plus 3j plus 7k, and B equal to I minus 4j plus k. Alright? And then they ask you to find B. They ask you to find B dot A. B dot A. Okay, equal to what? And I'm adding this one, A dot B. Alright? I want us to do this. Now, I like my notation. I like this notation, it's nice. 5, 3, and then 7. I like this notation. B, like the B will be 1. I'm just taking the coefficient of the I and so on, okay? Like this. Okay? Now, I'm gonna do B times A. Vector B times A, it will give you what? B times A, it's gonna give you 1 times 5 plus minus 4 times 3 plus 1 times 7. Okay? This one will give you what? I'm having here, it's going to be 5. This one will give you 12. This one will give you 7. So I'm having 5 plus 7 minus 12, which is 0 actually. Which is 0, alright? And then this one, A dot B, it will be the same thing, so it's going to be 5 times 1 plus 3 times minus 4 plus 7 times 1, which will be equal to 0 as well. So what does it tell you? What does it tell you? It tells you that vector A dot vector B are perpendicular. They call it perpendicular or octagonal. Alright? Now, the next question, question 12. Question 12, they say, show that the vector 7 plus, okay, we already saw it. Alright. They say, show that vector 1, which is 7i plus 2j minus k, 7i plus 2j minus k, and d2 equal to I minus 4j plus k are perpendicular. Now, what was the rule? The rule says vector A is perpendicular to vector B if their dot product is equal to 0. Now, let us find it. So here in this case, it's going to be vector 1 dot vector 2. So it's gonna give you what? Vector 1 is 7, 2 and minus 1. Vector 2 is 1 minus 4 and 1. Okay? I like to write it this way. Okay? So V1 dot V2 is going to give you what? It's going to give you 7 times 1, which is 7. 7 times 1 plus 2 times minus 7 minus 4 plus minus 1 times 1. This gives you what? It gives you, this is going to give you 7 here, and this one going to give you minus 8, and this one going to give you 1. Did I copy everything? Alright. Minus 1, yeah. Alright. So, this one, according to this example, it's 4, it's 7, 2, and 1. 7, 2, and 1. And this one is 1 minus 4 and plus 1. It's going to give you, let me just make sure if I did copy exactly. Yes, I did a mistake. It is 7i plus 2j plus k. It's a plus k here. Sorry guys. It's plus k. Okay? It is a plus k. Plus k. Sorry. It's like this. Okay? So this will give you 7 plus minus 8, which is minus 8. 7 minus 8 is going to give you minus 1 plus 1, which is 0. Therefore, we can claim V1 is perpendicular to V2. Alright? So, the perpendicularity, it means the angle between them is 90 degrees. Or pi over 2. Okay? So that is. So if you know the laws, you don't need to do this because you have to find the angle and then you're going to claim that whether it's perpendicular, whether it's 90 degrees. Let's find the angle. The angle will be from this formula A dot B. Okay? It was A. You don't need to do that, okay? You don't need to do that, but if you want us to do it, we're gonna know it. Okay? It's like this: A, B, cos theta. Okay? From here, we're gonna find cos theta. We're gonna find theta will be equal to cos inverse of what? Of A dot B, right? A dot B. A dot B divided by what? Magnitude of B, magnitude of A, alright? So now, my theta will be equal to what? My theta will be equal to cos of, already I know A, vector A dot vector B equal to 0, so I don't need to find this one. So it's going to give me 0 like this. And then the inverse cos of 0 is equal to 90. 90 degrees or pi over 2 in rad. Okay? Alright, so let's move on. We continue our examples. We'll go to example 13. That says, well, example 13. Example 13. I should have done it when I did the first example, but anyway, let's go to the example 14. I should have done it right after this one, after example 2. Let us go to example 13 now. Alright, example 13 says, determine the component of 7i, the component of vector A, which is 7i plus 2j minus k in the direction of vector B, which is I minus j plus 2k. Alright? So I like to write it in this format. Okay? I like to write it in this format. It's going to be 7, and it's going to be 2, and it's going to be minus 1. And then this one, B will be equal to 1, minus 1, and then 2. So they are asking us the component of vector A in the direction of B. And we said, to find the component of A in the direction of vector B, you have to do the dot product of B and A divided by the magnitude of B. Alright? Okay. So A dot B will be equal to what? A dot B is going to be equal to 7 times 1, which is 7, plus 2 times minus 1, which is going to be equal to minus 2, and then minus 1 plus minus 1 times 2. Okay? Over, what is the magnitude of B? What is B? B is 1 minus 1, and 2. So it's going to be square root of 1 plus minus 1 squared plus 2 squared. Alright? So I'll end up having 7 minus 2 plus minus 2. Okay, double check this. Alright. It's going to be 7 minus 2 over square root of. This one will give you 1 square, will give you 1 is 4. It's going to give you what? 4 plus 6. So I mean like this. And this one will go to 4. This one is 4. So it's going to be 3 over 6. Square root of 6. So this one will give you 3 square root of 6. And then if you punch the calculator, you're having something like, where's my calculator? It's gonna give you like 1.222 what? Okay, 1.22. So it's 7, 6 over 2, which is 1.22, so on, right? So from now on, you already know. I'm sure you know how to do the scalar product, okay? You know how to find the angle, and you know how to find the component of a vector A in the direction of a vector B. Alright? So let's continue. Now, and then also one more point, you know how to find, if they ask you to prove or to determine whether A and B are parallel. Oh, A and B are perpendicular, okay? A and B are perpendicular if and only if the vector A dot vector B, it gives you 0, alright? Now, let's continue. Now we're gonna go to vector product. vector product. Right? That says something already. It's meaning your result will be a vector. Okay? A vector product, the result will be a vector. And a scalar product, the answer, the result will be a scalar. Alright? So, now, consider V1, which is A, B, C, and V2, which is X, Y, and Z. Alright? These are two vectors. Now, V dot, or V plus, V1 plus V2. A vector product, okay, vector product, it's written V1 cross V2, okay? So this one, it's going to give you what? It's going to give you I, J, K, you do write this matrix, and then V1 comes straight. V1 is what? The component of V1 is A, B, C, and V2 comes the second will be X, Y, Z. So, I'm sure that you guys know how to find the determinant, alright? So the determinant, you have to know, you find it is going to be I. Let me change the pen. Unfortunately, you cannot use your calculator. You have to show the steps. It's going to be I, like this. You write plus. Alright? It's going to give you B, C, Y, Z. Alright? And then the second step is minus J. And then when you are in this line, first of all, okay, I'm sitting at I. I'm hiding this line and this column. I'm copying this. So when I'm sitting at J, what will happen? Which pen is this one? Blue. Alright. If I'm sitting on J, I'm gonna hide this and that. So I'll write those who are at the student is going to be A and X and C, Z, and then plus K plus K. When I'm sitting at K, I'm hiding this line and that's one. So it's going to be A, B, and then X, Y. Alright? Now let us do one example. Alright? Let us do one example. Alright? So, I'm having vector A, which is 1 minus 1 and 2, and vector B. Let me write exactly what was there. Was it? It was vector A, which is I minus J plus 2. Okay. And then vector B, which is 2I plus K. Alright? Like this. Now, they are asking you to find A cross B. A cross B. A cross B. A cross remember, I like to write my equation in this format. It makes my life easier. Okay? It's 1 minus 1 and 2 here. Now, vector B will be equal to what? I'm having 2. I have 2I plus k. Something missing there. It's 0j. So j is 0 and my k equal to what? 1. Alright? So it will be equal to start by ijk. Alright? ijk. The first vector is a. It's this one. It's going to give you 1 minus 1 and 2. And then the second vector is b, which is this one. It's going to give you 2, 0, and 1. Alright? So now let's start solving it. I'm here in I cover the rest. It's going to be minus 1, 0, and 2, 1. J minus j, and then I'll have, I'm sitting right here. I'm sitting here, I'm cancelling these two, so I'm going to write the extreme, which is 1, 2, and 2, 1, plus k. Now, notice that my I is always positive, my j is always negative, and my k is positive. Alternatives. You start by positive, j will be negative, and then k will be positive. So I'm sitting at k, I will have 1 minus 1, 2, and 0. Alright? Let us solve. I believe you guys know how to solve the determinant, but I will do the full step. It's fine, it's not a problem. I'll do it. So in determinant, you multiply like this and then you minus like that. Alright? It's gonna be like this. This 1 multiplied by minus 1 multiplied by 1. When you go this way, you have to put minus first. So it's something like this. Something like this. Minus 1 times 1 multiplied by 0 times 2. Alright? And this side is going to give you what? I'm having 1 times 1 times 1 minus 2 times 2. Alright? When you go down, it's multiplication. When you go up like this, it's going to give you negative. Alright? And then minus. And then this one is going to give you 1 times 0 minus 2 times minus 1. Alright? So basically I'm having minus 1 times 1 is 1. This one is 0, so I'm going to have minus 1 here. Alright? This one is what? It's 1 minus 4, which is minus 4. Alright? And this one is going to give you 0 minus 2. It's going to give you plus 2. Alright? So my answer will be equal to which is minus j, alright, minus j minus 4, it's going to give you plus 4j, you're multiplying them, right? So we have k times plus 2, it's going to give you plus 2k, alright? That is how you do it. This is a vector cross b vector. It gives you a vector. Alright? Now, Let's look at question 2. Question 2 is like this. Of course, I'm not gonna solve all the questions for you. So you have to practice. Those are leading, so you have to do it. So I'm adding question 2, which is A equal to I plus K, alright? And then vector B equal to 2I minus J plus 3K. And then vector C is equal to I plus 2J plus 3K. Alright? Now they ask you to find A cross B, and then also this is 1, and then 2 will be A cross B cross C. Alright? Let's find this. Remember, I like to note like this. A will be equal to 1, 0, and 1. My B is 2 minus 1 and 3, like this. Okay? And then I ask us to find A cross B. It's going to be I, J, K. And then our 0, 1, 0. 2 minus 1, 3. Alright? So I have to find this. This will give you what? I determinant. Okay? I 0, 1 minus 1, 3. Alright? Minus J. With 1, 1, 2, 3. Plus K. 1, 0, 2 minus 1. Like this, alright? So, let's do it. It's going to give you 0 times 3, which is 0, minus 1 over 1. 0 times 3. Can you write it properly? It will be I, 0 times 3, alright? Minus 1 times 1. Like this, you close the bracket, minus J, you open the bracket, it's going to be like this, right? Like this. Always start by like this, and like that. Alright? It's going to give you 1 times 3 minus 2 times 1. Close the brackets, alright, plus K, open the bracket, it's 1 times minus 1, minus 2 times 0, then you close the bracket, okay? This will give you what? This is 0 times 2 is 0, and this one is going to give you minus 1 times minus 1 is 1, alright? And then here it will give you 3 times 1 is 3, and 2 times 1 is 2. Alright, so it's 3 minus 2, which is also 1. Okay? And then here it's going to give you a minus 1 times 0, it's going to give you minus 1. So my final answer will be equal to space. It's going to give you 1I. Alright? This one is what? Minus 1J. And then minus K. 1K. Alright? That's your answer. Now, let's do A cross B. A cross B. Let's see. Is like that? Did I copy it correct? C. No, I didn't go with correct. Alright? It's A cross B plus C. I like this example. So let's do this. So you have to follow some logics. Logic. Okay. The first thing to do is to find what is B, vector B plus vector C. Okay, I'm having vector A cross vector B plus vector C. Alright? So now my number one will be to find B plus C. Alright? What's my vector B? My vector B is it's 2 vector B equal to 2 minus 1, 3, right? Like this. And my vector C, what is C? The C equal to 1, 2, and 3. 1, 2, and 3, like this. Now, they ask you to find vector A plus vector B plus vector C. So I'm going to just add that, right? B plus C. Look at how easy it is. It's going to give you 2 plus 1, which is what? 2 plus 1, it's going to give you what? 3. 1 minus 2, it's give you what? 1. 3 plus 3, it give you what? 6. This is it. Now, what is the next step? The next step is to do the cross multiplication. I have my A and I'm having my B cross, I'm having my B plus C. Like this, I'm having A cross B plus C. Alright? So I'll have this. What is to be I, J, K? Alright? What is A? Your A is 1, 0, 1, and your B plus C is 3, 1, 6. Like this. It will be I upon this 0, 1, 1, 6 minus J. It will be 1, 1, 3, 6 and plus K, which is 1, 0, 3, 1. Alright? So this is the way I like to do it. It's going to be 0 times 6 is 0, minus 1, it's going to give you minus 1. So I'm having minus 1 here. I'm having minus 1 here. But here it's 6. 1 times 6 will give you 6. Minus 3 times 1 is going to give you 3. It's going to be 6 minus 3. It's giving you 3. Alright? I'm having 3 here. And then here it's going to be 1 times 1, which is 1, minus 3 times 0. 1 times 1 is 1, minus 3 times 0, which is 0. So I'm going to have only 1 here. So my equation will be equal to minus I, minus 3j, and then plus k. Like that. So, what else? Let us for another question. And this question here. Yep, they are asking question number 4. They ask you vector v1 is 0.2, and then vector n5 minus 5, and then vector v2 is minus 1 and 25. So are they parallel? Now, we know, what do we know? Two vectors, a1, b1, they are parallel only if a dot b equal to 0. Okay? Now, I was saying vector A is perpendicular to vector B if and only if vector A dot vector B equal to 0. Now, vector A is parallel to vector B if A plus B equals to 0. Alright? So for the parallelism, we have to do the cross product. Cross product or vector product. Okay? We call it sometimes cross product or vector product. Also, there's another formula for parallelism. It means A is parallel to B if A equal to NB. N is different from 0. Alright? N is different from 0. Alright? So it means if I'm having vector A equal to 1 and minus 5, and then vector B equal to 2, like this, which is 2 and minus 10, I can claim that vector A is parallel to vector B because I can write this as the factor of 2, 1 and minus 5. Alright? I don't know if you can see my cameraman, I don't know if, yeah, that's it. So let's solve this question. It will be our last question for vectors. This will be our last question for vectors. And I wish you all the best. I hope it was helpful. So, the question? Okay, I'm going to write the full question. It says show that vector what? 0 to 2, alright, and minus 5, like this, minus 1 to 5 are parallel. So let's call this one vector 1, v1. It's 0.2 and minus 5, right? And vector 2 is minus 1 and 25. So v1 cross v2. If these two are equal to 0, we can claim that this function, these vectors are parallels. Okay? remember this. We say V1 is parallel to V2 even if V1 is equal to n V2 or V1 plus V2 is equal to 0. Let us do this one, cross multiplication. V1 plus V2, alright, is going to give you what? I'm going to have 0, 2, minus 5, minus 1, 2, 5, like this, alright? And then it's 5. It's going to give you what? 0.2 times 25 minus 1 times minus 5. So this one gives you what? Minus 5, minus 1 minus 1 will give you 5. And 0.2 plus 0.2 multiplied by 25 is going to give you 5. So I'm having 5 minus 5, it gives you 0. Hence we prove that V1 is parallel to V2. Okay? V1 cross V2 equal to 0, therefore they are parallels. But there's another way to solve this question. V1 equal to what? 0.2 minus 5 and minus 5, okay? And then V2 is minus 1, 25, like this. Look at it. We can clearly see V2 equal to V1 equal to minus 5, 0.2 minus 5, like this. If you show you like this, if you show the lecture like this, it's correct. It's showing you that they are parallel. So it's like this, it's going to give you 1. Minus 5 multiplied by 0.2, it gives you what? It gives you minus 1. And minus 5 multiplied by minus 5, it gives you 25. Alright? I already used the calculator, but I'm pretty much sure it's like that. Right. So you can claim that your V1 equal to n you can claim that your V2 equal to n V1. So V2 equal to, it's been V2 equal to 5 V1 is this one, 2, this one, okay? So this respect to the formula that says K V1. This one. 2. Okay. Yeah. So for today, we are stopping right here. What else can I say? Yeah, that's it.